Thanks, John. I also would like to welcome you to our today's webinar to talk about our electrification solutions for automotive. Thank you very much for attending and taking the time to learn about our company and our product solutions. But before we start, I would like to introduce myself quickly. My name is Dennis Ditzel, and I'm working as Sales and Business Development Manager at Parker Lord. I'm located in Germany and responsible for our thermal management solutions, adhesives, and protection coatings. I'm working in the sales area for automotive for more than 12 years and involved deeply or 100% in e-mobility since the last 4.5 years. Today, I'm glad to present and be a part of our today's webinar. But before we start, Christoph, could you please introduce yourself?
Thank you, Dennis, and thank you all for attending this webinar. So my name is Christoph dos Santos. I'm application engineer team leader here in the EMEA, covering most of the OEMs and tiers related to electric vehicles. As a background, I'm a chemical engineer. I'm with Lord now a little bit more than 4.5 years. And I've been spending most of my career working on materials dedicated to protection, assembly, and thermal management for electronics.
Perfect, and thank you very much, Christoph. Let's move on. Today, we would like to talk about the 4 W's of thermal management. What is it? Why do we need it? Who needs thermal management and when? Next section will be electrification solution overview about our products, followed by material dispensing and handling, a very important topic, and common applications. But before, let's take a look on Parker Hannifin. At Parker, we have more than 3,000 product lines. In global revenue, we are above 14 billion. We work with more than 450,000 customers worldwide, and we have more than 56,000 team members worldwide. At Parker, we have a global distribution network, operate in 50 countries. We have around 290 manufacturing plants and serve more than 1,000 markets. So we are a global player with local focus. Let's move on. Who is Parker Lord? On this slide, I would like to present Parker Lord. Inside the Parker organization, we are linked to the ENG group, Engineering Materials. Who are we? We are a collaborative partner for our customers. As mentioned, we have a large portfolio with different production solutions, but we're still open to develop or modify materials to meet specific technician or commercial needs of our customers from the beginning. Thereby, we're building up long-term business relationships, collaborate together to find solutions for challenges, and being successful together. Additionally, we are operating globally. On the following slide, you will see a global overview of our manufacturing places. But additionally, we have more R&D centers and office locations all over the world. Here you can see our production places. Our headquarters is in Cary, North Carolina, and there's also a large R&D center. Our production places are in Seagertown, Pennsylvania, Indianapolis in Indiana, and we also produce material in Japan, China, Brazil, and last year we opened a brand new factory in Germany in Hückelhof and already supply local produced material to our customers. On this slide, you can see some examples of application areas where our materials are already in application. Infotainment, we have special design products for e-motors. We have special design materials for the charging infrastructure, headlamps, LEDs, and of course, battery packs. Our expertise. Beside the automotive market, we have customers using our products for e-mobility in other areas like EV buses, electric marine vehicles, energy storage, but also LEDs, microelectronics, aerospace, and industrial e-motors. Today, we will present several of our product solutions. If you like to get more details about all our material solutions, please visit our homepage. As mentioned before, we have a large product portfolio. We have multiple chemistries. We work with products based on silicone, PU, epoxy, or acrylic. At the end, it depends on your part or design. Our sales and application engineering teams are happy to support to find the best suitable product choice or collaborate together at new developments. So now it's getting serious and we need your technical expertise, Christoph.
Thank you, Dennis. So, thermal management materials. In the next coming slides, we will cover different aspects of electrification with a focus on materials that could be used in EVs. And to start with, I will start with thermal management, what it is, why we need to take care about it, and what is the impact on the application you can find in electric vehicles. So basically, when we talk about thermal management, we are referring to transferring heat from hot components to a cold plate or heat sink. Those components or hot components may include things like batteries, semiconductors, inductors, transformers, capacitors. And thermal management could be actually passive, using thermally conductive materials, for instance, or active, utilizing forced air or forced liquids. So why is thermal management important for electronics? You can look at different aspects. Of course, you have the performances, and usually you want to have long-lasting performances. And of course, you're looking at reliability and also charging. So basically, when you talk about performance, everybody wants products that are fast and develop more power. And they are also becoming more and more small. So that means that you have more and more heat generated with small components. So you need to manage the heat and making sure that the heat remains at an acceptable level. Talking about reliability, exposure to heat shortens the lifetime of the electronics. And that's something that you need to keep in mind. Also, temperatures should be as low as possible, again, to be able to extend the lifetime and having all those components processing normally. And thermal management materials are there to help decreasing the working temperature. If you look at charging, electronic components that require charging, like lithium-ion batteries, will heat up when charging, and that's something that needs to be controlled. Components are rated to certain temperature, so you need to make sure that the temperature remains at a certain level and not go over. If energy input is severely limited, charging will take too long, or in the end, you could damage your components. So basically, if you look at electronics, and as I previously said, I've spent more or less 20 years in materials dedicated to electronics. Everything started more or less 40 years ago. As said previously, electronic devices became smaller and smaller and generated more and more heat. And all these components, you can find them in various markets like automotive, lighting, energy storage, transportation like electric vehicles, laptops, smartphones, and everything related to microelectronics. So again, what you tend to do here with thermal management material is to improve the efficiency and making sure that all those components will last over time. And that's where everything started with thermal management.
Hey, Christoph, I apologize. I would like to make a comment here. A well-elaborated thermal management concept is one of the important topics to reach good performance in long part lifetime. So when to think about thermal management? As soon as possible. Think about the thermal management concept from the beginning of your part design. Involve thermal interface material experts from the beginning and collaborate together to find the best suitable solution. In the past, we saw a lot of bad examples where thermal interface materials or thermal management was not considered from the beginning. And then it was very difficult to find an optimal solution to remove heat out of their parts. And Christoph, thank you.
Thank you, Dennis, for this very valid comment. And indeed, I can insist on that as well. You can usually get to way better performances when you think about the design, including thermal management from the very beginning, rather than trying to retrofit some thermal management material when the design is already locked. So how to choose the right thermal management material? Basically, you are looking at the best performances, but depending on the performances you are looking at, you need also to dig into the different chemistries available. The way that you do the assembly is something that you need to consider as well. And then also the application. So as you have to include thermal management from the very beginning in the design, it's also important to keep in mind that dispensing is a key element. when you try to manufacture all these components. On the market, you will find multiple solutions with regards to thermally conductive material, and it's important to consider the design of the part from the very beginning and to look at the performances over time. Electric properties, resistance to flame, reworkability are some of the performances you need to look at. Assembly time and dispensing should also not be neglected. And based on all those requirements, you can make an appropriate selection among various chemistries like silicone, epoxy, urethane, acrylics. Silicones are usually user-friendly and soft, but could be an issue when adhesives needs to be applied or painting must be done later. Urethane can be soft as well, but are sensitive to moisture when in cure, so you need to take that into consideration on the manufacturing line. Epoxy and acrylics are hard and develop usually very good adhesion, which is not always compatible if you need rework, for instance. This shows how important it is to clearly define the needs before making the product selection. So after this first part, it's probably time for our first poll question. And this poll question is as following. What is your most important criteria for thermal interface material? Should it be fast curing, silicone-free? Is it price of the material? Is the level of thermal conductivity? Or are you looking for extremely low density materials? So we'll give you a few seconds to respond to the poll question. Thank you everyone for your feedback. We'll continue on with the presentation now. As mentioned previously, we have a diversified product portfolio going from potting and encapsulants, going through gap fillers, and including also structured adhesives. So basically, potting materials are usually low viscosity and soft material, usually 2K, but sometimes you can find 1K as well. Dispensable materials, so they are liquid dispense. They provide some mechanical strength as they are used to embed all the components. Gap fillers are higher viscosity materials becoming a very soft and tacky material, which helps absorbing vibration and ensure keeping a good contact between substrate, like the hot component, as mentioned previously, and the cooling plate. Structural adhesives are hard and develop real chemical bonds and therefore provides good mechanical strength, but rework in that case is not an option. Talking about potting and encapsulation. As I just said, it's usually a low viscosity material, self-leveling, which allows you to embed all the components. It's designed to displace air because, as you probably know, air has a very low thermal conductivity. And the goal here is to replace that air with a material with a much higher thermal conductivity. You can find different definitions of those low viscosity material. As it's mentioned here on the slide, you have potting materials, which are there to filling the space around the components. Encapsulation, where you're filling the space around components and the material becomes the outer housing. You can talk also about sealing, where you are then covering the exposed sides of a component within a housing. And then the last one that you can find as a definition is casting, where it's like a molding material into a specific shape pattern with a housing. Those materials can usually be cured at room temperature, but you can also accelerate the cure by using some heat, depending on the components you are working with, if they can accept heat or not. And they can be easily applied by pouring because it's a very low viscosity material. And if needed, you can also use cartridges, syringes, or for larger production, you can go for a fully automated system for dispensing. So going a little bit more into details about potting and encapsulant material. As you can see here on the table, and as mentioned previously by Dennis, we are working with different chemistries where you can find silicone, polyurethane, and epoxy material. And again, it depends on which type of material you are looking for. Do you need something hard? Do you need something soft? Do you need something with very good resistance to solvents? Do you need something that has very high thermal conductivity, etc., etc.? And if you go through, for instance, thermal conductivity, you see that you have an offering going from 0.7 up to 4, and even for 4, like the SE 324, you see that even for 4 watts per meter Kelvin, you still have a quite decent viscosity, which is around 30,000. And as I said, you have different hardnesses. You have soft materials in the short A range, going up to the short D range for much harder material, again, depending on the requirements that you have. So in terms of manufacturing, you can think about packaging. So those materials can be supplied in cartridges or in bulk, depending on the volumes, obviously. The storage is usually at room temperature, so no specific requirements there. And you also do not require rotation or agitations to keep filler dispersed. It's slightly different when you start to use the material, because as you have a low viscosity material with filler having a higher density, before use, in that case, you need to steam the material, but not during storage. Those materials can be, as mentioned previously, dispensed by cartridges, or for fully automated system, you can go with an MMD equipment. Of course, using cartridges, you need a proper setup guideline to be sure that you have a material which is homogeneous and that will be dispensed as required. And for the dispensing system, of course, as those material contains filler, you need to make sure that you have the appropriate one, because something that could be used, for instance, for adhesives may not be appropriate for a material containing fillers, which may be abrasive. So after reviewing potting and encapsulating materials, the next type of material or thermally conductive material that we offer are the gap fillers. As said, these materials are also liquid dispense. They can be 2K or 1K. They are usually higher viscosity, much higher viscosity than potting and encapsulating material, with some specific rheological properties like non-sack properties, but also shear thinning. They cure in place. They can be used as a thermal interface in large-scale applications between the hot components and the heat sink, where great adhesion is not really required. And this is especially the case when you would like to do some rework in the field. If one of the cells is damaged, you can then easily remove one of the cells or the module to do a repair. They need to be serviceable, which means that those materials need to be dispensed rather easily, because otherwise you will not be able to apply on a very large surface. And it's often an offset to thermal pads in large case, because it's a liquid dispense material, as I previously said, which makes it very easy to dispense on large surfaces. They are usually room temperature cure, but can be heated. Again, it depends on the type of component it's applied to. And they can be easily applied by using, again, cartridges or fully automated system, so meaning using MMD systems. Now that we've covered a little bit on gap fillers, it's time to launch our second poll question. What kind of gap filler do you prefer? And here you have multiple choices. So we'll give you a few seconds to respond to the poll question. Thank you everyone for your feedback. Let's continue on. So going a little bit more into the details about our gap filler offering, here again you have multiple chemistries. Basically here parcolored silicone and urethanes. You see that you have thermal conductivity available going from 3 watts up to 3.7. And one remarkable thing maybe is for the SC3000LD, where you still have a thermal conductivity around 3 watts, while the density is only 2.4, which is quite remarkable for a gap filler with this level of thermal conductivity. As you can see, there are some of the products which are also UL94V0 rated, meaning that they have a pretty good flame resistance to flame. I think that UL94V0 is known by most of the audience. And as I explained, most of those materials, the gap fillers, they are relatively soft. Remember that for the potting material, we had the short A range, which is already soft, but in this case, we are in the short 0, 0 range, which is even softer than the potting material presented before. And then we have one option, which is slightly harder. And this is again, depending on the requirements that you may have. So the gap fillers, They are also available in large bulk containers, going from half a pint to drums. In terms of storage, again, we are talking here about the storage around room temperature. Rotating the containers here can help prevent some settling. Hard pack may occur, so agitation again will be required before using the material with the MMD system. Urethane, I think I mentioned that at the very beginning. They are sometimes sensitive to moisture, so you need to take some special precautions there. And urethane hardener may crystallize when stored or shipped at low temperature, but a gentle heat up should help you to get rid of this crystallization. In terms of dispensing, typically you need a metal mix dispensing system. That's what we call MMD. For high volume production, it requires agitation and degassing before dispensing. Filler may not always be compatible with all type of system, again, due to the fact that it's heavily loaded with fillers, which may lead to some abrasion of the parts. Some products require preheating as well to decrease the viscosity, for instance, or just to keep the same temperatures wherever you are on the globe. And some products require recirculation to prevent again the filler to settle in the feed lines of the MMD system. So we covered already potting materials, gap fillers. So let's spend some time now on structural adhesives. Why structural adhesive in EVs? As mentioned, those materials develop a real chemical bonding, so it allows to have a very good mechanical strength of the whole structure or the whole part, but which means also that in that case you cannot rework. So talking about structural adhesive, here we are talking about products which are typically thixotropic materials, as I said, used to bond two substrates together. They are dispensed as a bead, so it's also a liquid dispense material. It can be used to bond similar or dissimilar substrates. So it could be metal to metal, or it could be metal to thermoplastic, often used in lightweighting parts. So this is typically what people try to achieve, is to get lighter and lighter parts. So it could help you to get rid of some mechanical fastener, and that's one example. It gives you also some more freedom in the design compared to a mechanical fixation. Sometimes they could be structural adhesive and thermally conductive materials. In that case, you have the structural bonding, but in addition, you are able also to remove some heat from the hot components. There can be two components or one components. The two components are typically used for larger parts and when it's preferable to work at room temperature. And the 1K are typically used for printed circuit boards, called also PCB. And they can be easily dispensed using cartridges again or automated dispensing systems. So as usual, let's have a look on some of the offering that we have. Obviously, it's as for the previous projects, it's only a snapshot. So there is much more available in the portfolio. Here, basically, you have material based on acrylic, because acrylic are known to develop usually some good adhesion, but you can also find some urethanes, and there are some other chemistries that could be adapted for this kind of applications when adhesion is required. You can see that the adhesion can go up to something like 19 as lab shear strength adhesion, which is relatively high. And then you can also adapt in terms of working time, which is very important. When we're talking about process, sometimes people want to be very, very fast. In other cases, they want to slow down a little bit for various reasons. And also you have the glass transition here. Of course, in the technical data sheet, you have much more information, and you are always more than welcome to come to us to ask for some more information if needed. And here I will pass on to Dennis again, who will cover the next topic, which is the coatings.
Thank you, Christoph. Let's start to talk about protection coatings. We have two different kinds of coatings in our portfolio. One is a flame-resistant coating. Fire around or inside battery packs are one of the biggest safety concerns for electric vehicles, and we have a coating to slow down the thermal runaway. The second coating is our dielectric coating, JMC 700K. This coating allows electrical isolation between cells. or cooling plates. It's an alternative option to thin film as typical solution. Right, let's take a deeper look on our FR coating. We have several different versions of ZPOL FR. We have solvent-based material, water-based, 1K or 2K systems. For electrical vehicles, there are several different areas that are susceptible to fire. The first is battery cells within the pack, which may catch on fire or propagate fires from cell to cell. A second option could be inside of individual model, where CPO FR can be applied to prevent fires with the model from escaping and propagating to other models in the battery. The lid of a battery box can also be coated to prevent fires from escaping the battery pack and impacting passengers. Another option could be to use the coating in the battery pack itself, which is susceptible to fire ongoing in other areas of the car or from external fires to the road. Coating outside of the battery pack prevents external fires from causing cell fires within the battery pack. And last, our coating can be applied on the bottom of a chassis to prevent both external fires and battery pack fires from impacting passengers. We prepared a short video. You can see how CPO FR protects a thin piece of aluminum from temperatures up to 1200 Celsius. Without the coating, there will be a hole melt through the coating within 15 seconds. But when the aluminum is coated with ZPO FR, it expands with 5 seconds to protect the substrate. This video only shows results up to 10 minutes, but we run tests up to 95 minutes without seeing any melting in the aluminum part. We saw in our tests that coating as thin as 25 to 50 microns are sufficient to protect aluminum for substrates with lower melting points. Thicker coating applications are used.
And one thing I can add, Dennis, is also that it not only it protects from fire, but also it helps to keep the temperature down at the backside of the panel, which may be very useful as well.
Absolutely right, Christoph. Thank you very much. Good. So let's move on to our dielectric coating. Our coating is based on epoxy, and that provides excellent electrical isolation. Our product can be applied by spray or dip methods, and it offers reduced thermal impedance compared to plating due to thinner layers. It has a less prone to cracking than traditional plating methods. Our coating is environmental resistant and protects against high heat and corrosion. And of course, it's electrical insulative. Typical applications could be cooling plates, battery boxes, housings, or permanent magnets for e-motors. Before we move on our next topic, material dispensing and handling, we're going to launch a third and final poll question. Would you agree involving your material supplier in a discussion with your MMD suppliers at the beginning of a project? Is it important for you? Please pick 1 if it's not important, or 5 if it's very important. We'll give you a few seconds to respond to the poll question. Wonderful. Thank you everyone for your feedback. I'll handle it back over to Christoph, who will speak more about material dispensing and handling.
Thank you, Dennis. So let's move on and try to focus a little bit more on what is metal mix dispensing machine, also called MMD. Basically, that's also an aspect that should not be neglected. As for selection of a material, you need to understand exactly what are the requirements you need in the application. But something that should be considered as well is how you are going to dispense the material. And as you can see here on the slides, there are different systems, and it's important to engage with the MMD supplier at a very early stage, because again, depending on the manufacturing pace you want to achieve, the type of material, is it high viscosity, low viscosity, very abrasive, not very abrasive, fast curing, not fast curing, etc., etc. You have several options, and basically the MMD supplier has all the experience to help you making this selection. So basically, the metal mix dispense system is there to dispense or to transfer the adhesive or the gap filler or the coating material from the bulk container accurately. and also work on the ratio, making sure that when you have a one-on-one, you really have a one-on-one dispense material. And if you have a different ratio, making sure that the ratio remains stable and accurate over the whole manufacturing process. It can be integrated into a semi-automated or fully automated system. Again, it depends on the manufacturing base you want to achieve and the volumes that you need to dispense. So in this table, you have a snapshot of the different systems that can be found on the market. So meaning progressive cavity, road displacement system, gear system, piston pump, or vacuum potting. And again, it depends on the type of material you want to dispense. As you can see for progressive cavities, for instance, you see that you can dispense gap fillers, thixotropic adhesives, material containing glass beads, also potting materials, so meaning very low viscosity materials. If you look at road displacements, you have basically the same options in terms of material that you can dispense, except that maybe for lower viscosity, it's not the most suited system. And then you have the gear system, where low viscosity is usually the one that you will dispense with, the piston pump, and the vacuum potting. So basically, these are just information that we gathered over the time, but it's clear also that the MMD equipment supplier are continuously developing their systems, like we are continuously developing our materials. So as I said previously, it's really important to engage with them from the very beginning of your projects to make sure that they can come with the right selection of the right system. As I said, you have to understand also which chemistry you are working with. You know that we can provide material based on acrylic, epoxy, urethanes, and silicones. And sometimes there are some compatibilities or incompatibilities, as you can see, for instance, with acrylics, you can use stainless steel, you can use PTFE. But if you look at silicone, for instance, it's not really recommended to work with rubbers as hoses. So there are different materials that sometimes are compatible, sometimes not. So here again, it's important to talk and with the material supplier together with the MMD system supplier to make sure that all this material can cope together.
Christoph, sorry, I need to jump in again and like to comment here. We are talking about chemicals, and technical data sheets and safety data sheets are very important. All our materials are REACH conform, and required documents are available on our homepage, or feel free, just reach out to us and we can provide all required data sheets you need. That's it. Thank you, Christoph, and please continue.
After reviewing the different materials that could potentially be used in electric vehicles, let's focus maybe a little bit more on the different applications where those materials can be used. Because when we talk about EVs, indeed it's a car, but there are many different aspects that needs to be covered and different types of applications. So that's why I will spend a little bit more time talking about the different applications where those materials could potentially be used. Basically, one of the things that you will face in EVs, and not only in EVs but also in I would say in standard cars, it's power electronics. If you remember earlier in the presentation, I explained that thermal management started more or less when electronics became smaller and smaller and generated more and more heat, and this is still the case today. When you look at power electronics, that's also different components that can generate a lot of heat. They are submitted to a lot of vibration. Moisture can also be a negative aspect that they have to cope with. So definitely there also you need some thermally conductive materials. It could be either potting materials, so very low viscosity material that allows you to embed all the components, which gives you and thermal conductivity, but also gives you a little bit of mechanical strength and protection against the environment. You have adhesives that can be used to bond different substrate or different components. You have the gap filler, again, the soft and tacky material, which could be used to transfer the heat from some specific hot components to a heat sink. You also have gels with a very, very low thermal resistance that could be used. That's in the case where you have very delicate materials that needs to be covered by a material which is extremely flexible. And you also have the dielectric silicone materials that can give electrical isolation and protection, meaning that they have a high dielectric strength to prevent any electric breakdown. They are very low viscosity for a good displacement of the air and replace the air by something that has some thermal conductivity, and also to protect against the, the environment and vibrations that a car can face. Charging systems, that's definitely linked to EV. So what do you find in there? You have magnetics, inductor or transformers. Here again, they are generating a lot of heat, and this needs to be extracted from the different components. So that's why again you can look at different options in terms of thermally conductive encapsulants or gap fillers, more or less for the same purpose than explained previously. The potting material can ensure magnetism to remain cool, less than 6 degrees, for instance. That's something that we have seen in the field. It can be used on regular shaped components due to the fact that it's a liquid dispense material and the fact that it's a low viscosity material. It can also help to eliminate inductor hum, and the gap filler, the stay in place materials. Remember, high viscosity, thixotropic, soft and tacky. That helps increasing the lifetimes of the different components, but by also keeping a certain flexibility. Automotive lighting is another application that obviously you can find in a car. And for automotive lighting, you can need sometimes structured adhesive. And one good example that we offer for that is the Lord 7800. It's a fast curing adhesive with some adhesion that can be cured in something like 12 minutes. So that meaning that you can improve your cycle time and getting a higher throughput. It also helps to have rapid pressure leak test. So again, it helps you to speed up the manufacturing process, and also helps you to have more flexibility. It reduces wipe in production floor space, and it's developed with high quality in mind, meaning that they have UV dye, which is very useful in case you want to do some post inspection of the material after application. So structured adhesive is one type of material that can be used in automotive lighting, but not only, because when you're talking about automotive lighting, again, you have some electronics behind requiring thermal management. And there again, you have the option of the potting material, the thermally conductive gap filler, or potentially electrically conductive adhesives as well. One of the last application that we will review here. So it's the sensors. It's also something which is very common in the automotive world, if I can say so. And usually you need a high dielectric strength when you protect those materials. You need to protect from the environment. Again, we are talking about cars, so it needs to be protected from moisture, eventually from water splashes, from change in temperatures, and so on and so on. Basically, you need a material with a strong adhesion. It shouldn't be too expensive. It should be low viscosity. And last but not least, of course, it requires also heat management. So meaning that a thermally conductive material could be used. And in that case, you can use either potting and encapsulating materials. They provide basically a very good dielectric strength, capable of preventing electrical short circuits between components on the printed circuit boards. They are also there to protect the electronics from the environment. And in the end, the target is, of course, to improve the performances and keep the performances at a high level over the lifetime of the car. And also talking about assembly and installation. When we talk about assembly, we usually talk about engineered plastic, aluminum, and stainless steel. And for protection, we are here to protect the sensitive electronics from environments, but also from physical tampering. And installation means that we can provide low-cost installation able to withstand the elements without modification of the existing equipment. Infotainment, that's basically also what you can find in a car. When we talk about infotainment, we are typically talking about things like a navigation system, digital audio broadcast system, which in the end means that you have electronic components that generate heats. That heat needs to be removed, and those components also needs to be protected from the environment. So basically, we are always coming to the same requirements, even if there are always differences. And in that case, again, you can use potting materials, gap fillers, greases, underfill, all the, let's say, portfolio that Lord can offer to protect all those systems in the car. I'd like to thank you, the audience, for attending, and we are open up now for questions.